In today's video, we understanding the cost function of logistic regression and how we active the activation function and how does it work, right? So all concepts we will learn in this particular video, okay? So people going with us and understanding the all logistic regression concepts, okay? So first understand the simple linear regression, which is the linear model, okay? You will know about what is linear model. Basically, linear model is something like that. It's a graph, and let's one, three, four, and five. And this is basically zero, and this is a midpoint of the 0.5, and this is a one. Okay, this is a linear regression, right? And some points are came here. So in that particular case, the your base fit line is something like that. Okay, the base fit line is something like that. And this the equation of that line is the just sorry. This the equation of that line is the just theta of x is equal to theta 0 plus theta 1 x1. This is basically the for a one input feature, right? One input feature for that. That is the equation for a linear model. But when you learn about a logistic relation, so we need to skew, right? So for that we use the one concept that the in a logistic regression, we use the activation function, right? Activation function. Activation function. Activation function basically is sigma is equal to 1 divided by 1 plus e to the power z. That's function we are using in a logistic regression. And that's how affected the your graphs, right? That particular case you will see this line is basically line or straight line basically, right? Straight line. But what happening when we use the equation function? So how line are affected or how line basically is skewed that we will see in that particular video. Okay. So for a logistic regression, okay, let's understand that's for a linear model and we are draw for a logistic regression. Okay. So for a logistic regression, we draw simple graph. Okay. In logistic regression, we draw a simple graph. That is, we have data points, and this is basically zero, this one, okay, and this is a midpoint point five, point five. So okay, and when we draw the graph, so graph is something look like that. That is a graph. That is a graph looking like that, right? This is a graph looking like that. Basically, it means this is basically skew. We last video we will understand of the skewness. So when we add that active function, activation function, so that line will be skewed something like that, right? This is basically is not always is the output become less than one, okay, less than one and greater than zero. This is the output, okay. That's the simple concept. And when we draw for a cost function, so we'll say when we add okay, x theta of x is equal to sigmoid function theta 0 plus theta 1 x1. This is the for that this equation for that base fit line, right? This is base fit line for a logistic regression. Base fit line. Base fit line for a logistic regression. But problem is, and this value of z, okay, z. So basically, yes, theta of x nothing but yes, theta of x nothing but 1 by 1 plus e to the power z, e to the power e to the power 1. So e to the power z. That is your for a logistic regression equation for a just topic basically for this line when we add a equation function, right? So okay, that's for equation function. Okay, in next video we will understanding the cost function for logistic regression, right? When you see the linear regression, so the cost function is a 1 by 2m, summation of I to 1 to m, and basically just theta of x minus y. What is y? I hope you know about that. What's basically that is basically is a predicted point, and this are a actual point, right? That's I hope you know about that. That we will learn in a simple linear regression. Okay. So in that case, when you draw that cost function and we apply, so in that particular case, the graph, the cost function is with respect to theta of theta with respect to theta 0, theta 1, the graph is look like it's a convex function, right? This is basically convex graph that is convert, right? Convex graph, and this will be the global minima, right? Global minima. But in logistic regression, the cost function not convert the convex function. Basically, this cover is a non-convex, right? Non-convex. That's cover in a non-convex. So when you will see the graph, so what is non-convex? Basically, understand which is to theta, g of theta 0, and cost function is a 1 by 2m summation of I to m, I to 1 to m, just theta of x, right, minus y. And same is just theta of x nothing but is a y equation function of 1 by 1 plus e to the power z. What is z? This is z basically the theta 0 plus theta 1 x1. Okay. I that's a simple concept. But when you draw the cost function of that logistic regression, so the graph is look like something like that. It's a non-convex function, right? And this all know are a local minima. Local. This are all know are that's all are a local minima, and this is a global minima, right? These are a global minima, and these are a global minima. So when you see when you change the theta value, so theta value will be takes too much time, right? First is a conversion of the that's local minima, and then give another one, and then another local minima, so local minima, so the graph will be take up too much time, and that's a in a logistic regression. Okay. So, what happened when you denote it? Okay, so come here and understand one more concept is let's denote it, denoted denoted cost function basically, right? Denoted cost function, and we are denoted theta 0 is the okay. Sorry for the mistake. Okay, so in cost function we denoted some simple concept is a yes theta of x I, and second one is a I. Sorry, y to the power I. That's we are denoting, right? So when they use that denoted, so how the your functions or basically how the equation are look like, right? So we are understanding that basically after that we denoting the yes to of x and y. So your equation is look like something like that is a minus log to the yes theta of x if y is equal to 1, right? And basically you said this is a true point, yeah, true point, or basically it's a in according to that data set you will see according to the data set basically there is a path. Okay, path. And if what happening if y is equal to 0, it's mean the your equation will look like minus log 1 minus s theta of x, right? If the y is equal to 1 or is equal to minus log s of x, if the y is equal to 1, and if you want to y is equal to 0, it's mean the minus log 1 minus s theta of x, s theta of x, that is the equation you will see. So, your cost function, how your cost function look like, right? And this is basically a equation. So, how the cost function look like? Okay. So let's start with the cost function. So, cost function with respect to s theta of x I to the power 1 and y. So your cost function is look like something minus y log of h theta of x, right, minus 1 minus y, and there is a log of 1 minus s theta of x, right? After the conversion, when you replace the theta value, so there is a cost function, basically this is a cost function that we have for a logistic regression. Okay, that is a simple concept in a particular when you understand, right? That is a cost function for a logistic regression. That's you. So I hope you understand that all equation. Okay. And similarly, with respect to that, right? With respect to when we denoted the yes of x and y, and this is a real cost function, is something like this, a cost function with okay, sorry, this is a cost function with respect to g theta of 0 and theta 1 is nothing but 1 by 2m summation of I to 1 to m, and this is nothing but y of log x theta of x to the y minus 1 minus y, right, into log of 1 minus x theta of x. This is a cost function for a logistic regression. That is I hope that is simple concept you understand. Okay. And similarly, the uh, minimize the cost function, right? It's a part is the final aim. It is a final aim to minimize the cost function, right? So is a conversion algorithm we have when we want understand the conversion conversion algorithm, algorithm by changing theta 0 and theta 1 value. So the conversion algorithm conversion algorithm is looks like something that is a theta j is equal to theta j minus alpha. Alpha basically is the learning rate, right? And derivative of cost function. Okay, this all the concepts that you basically the theory part of logistic regression. Similarly, we all I hope we all cover all the concepts and understanding another one in a next video, right?